schedule? Today's our last day of material before test 3. So today we're going to cover some new material. Monday we're going to review. And Wednesday of next week we're going to take test 3, which is the last test before the final. And our last sort of thing before the final, aside from Project 5, which I will give to you next week sometime. But Project 5 is due May 15th, and it's in Moodle. If you want to start it now, you can start it. It's a review for the final exam. You probably can do all of it right now if you want. You're bored, looking for something to do this weekend, finished studying. Okay, so yeah, keep in mind test 3 is next week. Quiz 6, take home quiz 6 is due today. So please put that in the folder before you leave. That is your last quiz, yeah. Last quiz. All that's left after that is test 3 and project 5. Project 4 was due Monday. I only got like 8 of them. So don't forget that you have a week to get that in. So you could still give that to me Monday for a 10% penalty. We didn't hand it in yet. That's the student ID number. Yeah. All right, so today we're going to talk a little bit more about logs, and we're going to talk about some properties of logarithms. So we're on class 36 in the packet. So we're just going to warm up by evaluating some logarithms. So log base 2 of 32. Remember, that is asking you what the exponent is. What is the exponent that you raise 2 to make 32? 5. 2 to the 5th is 32. So log base 2 of 32 equals 5 because 2 to the 5th is 32. Okay. All right, log base 2 of 8 plus log base 2 of 4. Well, what is log base 2 of 8? 3, because 2 cubed is 8, right? So 3. Log base 2 of 4? 2. Yep, and 3 plus 2 is 5. So the answer to number 1 and the answer to number 2 were both 5, right? Log base 2 of 32 was 5, and log base 2 of 8 plus log base 2 of 4 is also 5. What can you conclude here? How are 8 and 4 related to the number 32? If you multiply 8 times 4, you get 32. So if I wanted to take log base 2 of 32, there's 2 ways I could do it. Log base 2 of 32. I could just do it directly and get 5, right? But I'm trying to demonstrate that there's this property where you could also say, well, 32 is 8 times 4. And then you can add the 2 logs. That becomes log base 2 of 8 plus log base 2 of 4. 3 plus 2 is 5. So if you're trying to take the log of a product, you can take the log of each factor separately, and then you add them together. So it looks like you're distributing this log to the 8 and to the 4, but then that multiplication sign in between them becomes a plus.
2 and 16 work the same.
Yep, but if you did it as 2 and 16, it would work the same. Yeah. All right, what's log base 2 of 16? What power should I raise 2 to make 16? 4. Yeah, 2 times 2 times 2 times 2 is 16. So log base 2 of 16 is 4, because 2 to the 4th is 16. All right, so now I'm going to do 2 logarithms and subtract them. What's log base 2 of 32? 5. What's log base 2 of 2? 1. 5 minus 1 is 4. I get the same answer here for 4 and 5. And how are the numbers 32 and 2 related to the number 16? 32 divided by 2 is 16. So I'm demonstrating this property here. If I want to take log base 2 of 16, I could do it directly like I did in number 4, or I could rewrite 16 as 32 over 2. And if you're taking the log of a quotient, you can take the log of the top and the log of the bottom, and it becomes subtraction. Okay, so this becomes log base 2 of 32 minus log base 2 of 2, which is 5 minus 1, 4. So again, it looks kind of like you're distributing, right? You take the log of the top and the log of the bottom, but the division sign, what's a division sign when it's in the parentheses? Becomes a subtraction sign. All right, log base 3 of 81. That is asking you, what power should you raise 3 to make an 81? The fourth power. Yep. So the answer to that one's 4. What is 2 times log base 3 of 9? So that's going to be 2 times, what's log base 3 of 9? 2. Yep. So the first 2 I copied from the expression, and then the second 2 is because I rewrote log base 3 of 9 as 2. And 2 times 2 is 4. So I get the same answer for 7 and 8. And how are 9 and 2 related to 81? 9 squared is 81. Yeah. So if I want to take log base 3 of 81, I can do it directly like I did in number 7 and just figure out what power do I raise 3 to make 81. Or I have this other cool property, which will always work. I could rewrite 81 as 9 squared. Instead of an 81, just rewrite it as a 9 squared. And then you can take that exponent, that 2, and you can bring it down in front of the log. So this is going to become 2 times log base 3 of 9, which is 2 times 2, which is 4. That is going to be a really important property when we start solving things, using logs to solve equations. All right, we got one more property, and then we're going to start using them for stuff. Okay. All right, what is log base 5 of 125? 3, because 5 cubed is 125. The answer is 3. Okay. Now we're going to use a calculator to evaluate the ln of 125 divided by the ln of 5. Okay, so if you have a graphing calculator, your ln button is on the left side, 3 up. ln of 125 divided by ln 5. Oh my gosh, it's the same answer. 3. Yeah. So what I changed the base, right? Instead of using log base 5, I used ln, but I took the ln of the 125 and I divided by the ln of the base, which is 5. Let's see, what happens if I use the log button instead of the ln button? If I do log of 125 divided by the log of 5. Oh, I also get 3. So you can actually change the base to anything you want. So I did base E and base 10 because my calculator has those buttons, so that turns out really handy. In fact, Abby, I think you were asking me yesterday, how do you get your calculator to do like a base 5? If you wanted your calculator to do log base 5 of 125, you could just type in either of those. Yeah. Okay. So what can I conclude about log base 5 of 125? Well, I can take log base anything of 125 and divide by log base the same thing, as long as you do the same on the top and the bottom, of 5, and that will give me log base 5 of 125. So it's easiest or most useful if you use a base of 10 or of E, because your calculator has those buttons. That one's called the change of base formula. So we just did examples of 4 really important properties. Here they are written out sort of algebraically. Okay, 4 useful properties of logarithms. If you want to take the log of a product, take the log of each factor and add them together. So again, it looks like you're distributing the log to your x and to your y, but the multiplication becomes an addition. Right? And if you want to take the log of a quotient, you can take the log of the top and the log of the bottom and subtract them. So multiplication becomes addition. It would make sense that division would become subtraction. If you want to take the log of x to a power, you can take that power p and bring it down in front of the log. And then if you want to change the base of anything, you just take the log of the top divided by the log of the bottom, and the base can be any new number you want. Did I start early? Oh, no, I started right on time. Yeah. All right, I've got 2 examples of applying these rules, once going forwards and once going backwards. Okay, so we're going to use properties of logarithms to expand and simplify this big expression. So I've got log base, so I'm trying to expand it, make it bigger, right? I'm going to take this expression and expand it, make it longer. So log base 5 of 25x squared z over y cubed. So my advice to you is to apply one rule at a time. You might have to write out a lot of lines, but you won't make a mistake that way. So the first thing I notice is that this is a quotient, right? So I'm going to do the quotient rule first. So I can take the log of the top and the log of the bottom and subtract them. So this is log base 5 of 25x squared z minus log base 5 of y cubed. All right, I'm not done expanding. I did one thing. I'm going to do one more step in the next one, in the next line. So look at this first logarithm, log base 5 of 25x squared z. That's a product, right? That's 25 times x squared times z. So I'm going to use the product expansion. So this is going to become log base 5 of 25 plus log base 5 of x squared plus log base 5 of z. And then I still have my minus log base 5 of y cubed. Any questions there? So I just did one step there. I had the multiplications and I distributed my log and changed those multiplications to additions. Because that's what the rule says. Okay, next step. Some of these things I can just evaluate. Some of these things have exponents. And when you have exponents, you can bring them down in front, right? So when you have an exponent, it can come down in front of the log. So log base 5 of 25, what is that? 5 to the x equals 25. Yep, so it's 2. So this is 2 plus, bring this 2 down in front of my log, and I have 2 log base 5 of x. Log base 5 of z, there's nothing I can do to that. There's no products, there's no quotients, there's no exponents. So this just stays the same, log base 5 of z. And then the last one, I can take the exponent and bring it down, and I have minus 3 log base 5 of y. So you can see why the direction said expand, right? This little expression here, with a single logarithm, got expanded to have now 4 terms. That's it. That's the answer. So now I'm going to do the reverse process. I'm going to take something that's expanded and try to compress it back together into a single logarithm. So I'm going to kind of be using my rules in reverse. All right, so the first thing I'm going to do is take any coefficients pop them back up into the exponents. So I'm going to take that 3, move it up. Take that 2, move it up. And take that 1/2 and move it up. So I'm going to have log base 4 of x cubed plus log base 4 of z squared minus log base 4 of w to the 1/2. All right, let's just look at the first two terms. That is the sum of two logarithms with the same base, right? Can I squish them together into a single logarithm? Yeah, how? Multiplication. It's the multiplication rule in reverse, right? So if I finished with two logarithms added together, I must have started with log base 4 of x cubed z squared. And then I still have minus log base 4. Instead of w to the 1/2, I'm going to write square root w. It's the same thing. Okay, now I'm subtracting two logarithms, right? So what must I have started with? Division, yeah. So this becomes log base 4 of the first one, x cubed z squared, over the second, square root w. So I took that big expanded thing, I applied my rules in reverse, and I compressed it into a single logarithm. Yes? 1/2 is a coefficient, so I moved it up into the exponent. Yeah, so w to the 1/2, if you remember probably from a previous course, that whenever you have a rational exponent, the number on top is the power and the number on the bottom is the root. So this is actually the square root of w to the first, which is shorthand written square root w. All right, one more example. I want to use a calculator to approximate log base 4 of 50. Right, so I don't have a log base 4 button, right? I only have an ln button or a log base 10 button. So I'm going to have to use the change of base formula. So log base 4 of 50, right? I can't think of a number in my head that I could raise 4 to make 50, right? Like 4 squared is 16, 4 cubed is 64, and I jumped right over 50. So it's somewhere between 3 and 4. Some number between 3 and 4 should be the answer here. I can get my calculator to tell me exactly by doing a different base, ln 50 over ln 4. Right? Or I could have used log. It doesn't matter. You can choose any base you want. So ln 50 divided by ln 4, about 2.82. Yeah, it should be somewhere between 2 and 3. 2.82. And you can check, right? That's the number that you raise 4 to it, you should get 50. So if I do 4 raised to that number, I should get 50. And then I just to reinforce, you don't have to use ln, you can use log too. Log of 50 divided by the log of 4, same thing, 2.82. Yeah.
Is it okay that we round it off?
Yeah, it depends on the directions for the problem. So if the directions ask for an exact answer, you would have just circled log base 4 of 50 or ln 50 over ln 4. And if they want an approximated answer, you would round. Right. Yep. Yes. No way. Not number 4. No. Yep. All right. I believe that's it. Now I'm going to let you do some practice.